Hello everyone. Today we will start with inorganic chemistry. Everything around us is made up of atoms. And what are atoms? They are the smallest unit of a chemical element that can exist without losing its property. Or you can say it still carries the property of the element. If we try to break it further, it will lose the property of the element which it is made up of. So will you not be interested to understand the structure of atom of which everything is made up of? For this, we'll have to take a look at brief history of how the models have evolved from the Greek marble model, which was the prevalent model from 400 BC to early 1800s. And today, with the help of quantum mechanics, we have a charge cloud model. So let us look at the evolution. So as I just mentioned, till early 1800s, atom was thought of as one indestructible whole, not having any internal structure. So by the end of 19th century, electron was discovered by J.J. Thomson in the year 1897 when he was studying the properties of cathode rays. And he suggested a plum pudding model for atoms in around 1904. And what did he suggest was atoms of the elements consist of number of negatively charged particles enclosed in a sphere of uniform positive charge. You can imagine it as a cake which was positively charged and electrons were embedded in it like puddings. By 1909, even the charge on electron was measured by Millikan in his oil drop experiment. And then this happened. The famous gold foil experiment. This was a landmark experiment. In 1909, Rutherford conducted his famous gold foil experiment. Actually, it was conducted by his associates Geiger and Marsden under his supervision. They bombarded a beam of alpha particles on an ultra-thin gold foil and then detected the scattered alpha particles on a zinc sulfide screen. And what were the results? Most of the particles passed through the foil without any deflection. Some of the alpha particles deflect at small angle. Very few, 1 in say 20,000, bounced back. This was very surprising. Thinking about this experiment after a few years, Rutherford said it was like hitting a tissue paper with a 15-inch cannon and it hit you back. So you can understand how important this experiment was. So after this experiment, there were some inconsistency found with the plum pudding model. So Rutherford concluded that most of the atom's mass and its entire positive charge are confined in a small core called nucleus. And as suggested in plum pudding model, most of the volume of an atom was empty space. It was also noted the number of negatively charged electrons dispersed outside the nucleus is same as number of positively charged particles in the nucleus, which explains the overall neutrality of the atom. So Rutherford was credited for having discovered protons. And the model was modified as you can see in the picture. So you can see in the Thomson model, the greenish portion was the positive part, wherein the pinkish part were the electrons embedded in a positive sphere. In the Rutherford model, positive particles were thought to be in the center of the nucleus with electrons all around it. And then came Bohr's planetary model. His model depicted the atom as a small positively charged nucleus surrounded by electrons that travel in specific circular orbit around the nucleus called orbitals. The structure was very similar to our solar system. But then there were some problems. Various experiments showed that the mass of nucleus is approximately twice the number of protons. So scientists started thinking about the origin of this additional mass. Rutherford postulated the existence of some neutral particles having mass similar to that of proton, but there was no direct experimental evidence. Finally, in 1932, James Chadwick, a student of Rutherford himself, was successful in discovering neutron after several theories and experimental observations. With this, a stable structure of atom was finally established. So in Chadwick model, proton and neutrons form the nucleus of the atom, and electrons revolved around it in fixed orbits. Now let us try to understand some important notations with regard to elements. Now always remember this. The thing that makes each element unique is the number of protons in it, because number of neutrons and electrons can vary. We'll look into it shortly. So whenever you will come across any element, you will see three things. First, the symbol of the element. Let us call it X for now. Second would be the atomic number denoted by Z, which would be in the subscript. Finally, the mass number denoted by A, which you will find in the superscript. So atomic number Z is equal to the number of protons, and we have just learned that it is what makes an element unique. For any neutral atom, number of positively charged particles will be always equal to the number of negatively charged particles. And finally, atomic mass is equal to mass of protons plus mass of neutrons. If you remember the experiment, it was observed that the entire mass of the atom is located in the nucleus of atom. And what do we have in nucleus? It's only protons and neutrons. And electrons were thought to be smaller particles which did not cause any deflection to the alpha particles. Just for your knowledge, weight of electron is roughly 2000 times less than that of protons and neutrons. So let us take one small example. Here you can see three different isotopes of hydrogen, which is protium, deuterium and tritium. Now let us try to find the atomic number, mass number, number of electrons, number of neutrons in these things. Let us take hydrogen 1 or protium, which is denoted as 1 in the subscript H and 1 in the superscript. So H becomes the atomic symbol for hydrogen. So can you tell me what would be its atomic number? Yes, the atomic number is the subscript part, which is 1 here. So can you tell me what do you infer from this atomic number? Atomic number is the number of protons in the nucleus. Now let us try to find the mass number. It is the superscript. Again it is 1 unit. So now can you tell me the number of electrons in it? The atoms represented here do not show any charge, so we can consider it to be neutral. And in any neutral atom, we know that number of electrons is equal to number of protons, and number of protons was 1, which was its atomic number. So number of electrons will also be equal to 1. Now finally the interesting one. Now can you tell me the number of neutrons in it? Mass number was number of protons plus number of neutrons. Number of protons plus number of neutrons is equal to 1, whereas number of proton itself was 1. So we can conclude there is no neutron in hydrogen 1, which is protium. So now let us take hydrogen 2, which is deuterium, and try to find these things. Atomic number, as already mentioned, is unique for every element. Now since the element hydrogen does not change, its atomic number will also not change. So it will be equal to 1, and which will also be equal to the number of protons in it. The mass number will be equal to the number which is written in superscript, which is 2. Now the number of electrons, again it is electrically neutral atom, and hence it will contain equal number of electrons and protons. Number of proton was 1, so number of electron will also be equal to 1. And now can you tell me the number of neutrons here? Yes, you are right. So number of proton P plus number of neutron N is equal to 2 this time, and number of proton P is 1. So 1 plus 1 will give us 2. So number of neutrons here is 1. Finally, we can move to hydrogen 3, which is tritium. Here again, since the element does not change, its atomic number will also not change. We'll have the atomic number as 1, which is also the number of protons in it. Now can you tell me the mass number? Again the number written in the superscript, which is 3. Again this atom is electrically neutral, so it will have equal number of electrons and protons. The number of proton is 1, and hence number of electron will also be equal to 1. And finally, can you tell me the number of neutrons here? Again number of proton plus number of neutrons here is equal to 3, and number of proton here is 1. So the number of neutron has to be 2. So now you can find its atomic number, atomic mass, number of neutrons, number of electrons and number of protons in it. Now, here are some review questions. Please pause the video and try to answer them. You can put down the answers in the comment section. I'll catch you in the next video with some more interesting stuff. See you then.